Digging deeper into what it means for something to be so small, we quickly discover that the structure of an atom defies everyday logic. Atoms are not solid balls, as early models might have suggested. Instead, each atom is composed of a dense central nucleus surrounded by a zone where electrons are distributed, though not in neat planet-like orbits, but as clouds of probability. The nucleus, where nearly all of the atom's mass resides, is itself astonishingly tiny, about 100,000 times smaller than the atom as a whole. This means that if an atom were the size of a football stadium, its nucleus would be like a pea at the very center, surrounded by what appears to be empty space, yet is the energy domain of electrons. The size of an atom is one of the most astonishing aspects of the natural world, a subject that beckons not only scientists but also anyone curious about the fundamental building blocks of reality. When we speak of an atom, we are dealing with measurements that push the limits of our comprehension, a scale so minute that even the most vivid metaphors seem to fall short. To grasp the true size of an atom, imagine a distance so small that a single strand of your hair could accommodate about 100 million atoms lined up side by side. This comparison, while remarkable, only hints at the profound smallness we are dealing with. Typically, an atom measures about 0.1 to 0.5 nanometers in diameter. To put it another way, a nanometer is 1/1,000,000th of a meter. Even a microscopic bacterium, itself invisible to the naked eye, is thousands of times larger than a single atom. This curious emptiness has mind-bending consequences. Nearly all of the matter we see and touch consists almost entirely of space. If you could somehow remove all the empty space from the atoms in your body, squeezing the nuclei close together so that nothing but the dense centers remained, you could compress a human into a volume smaller than a grain of rice, yet their mass would be unchanged. It's a thought experiment that underscores just how ephemeral what we perceive as solid matter truly is. The elusive behavior of electrons, governed by the enigmatic laws of quantum mechanics, further muddies the concept of atomic size. Electrons do not follow fixed pathways, but occupy clouds of probability, zones where there is a high chance of finding the electron at any instant. The edge of an atom is not a hard shell, but rather a fuzzy region where the chance of detecting an electron becomes vanishingly small. This subtle ambiguity means that atomic size isn't a precise number, but a concept best defined by the regions in which electrons most likely dwell. Modern instruments allow us to see atoms not by looking at them with light, the wavelengths are too large, but by probing them indirectly. Tools like the scanning tunneling microscope and the atomic force microscope have revolutionized our understanding, letting scientists detect the presence of individual atoms. By sensing changes in electron flow or tiny forces as a needle moves across a surface, these instruments create images at the atomic scale, transforming the theoretical into something we can actually observe and manipulate. It is in the outermost electron clouds, these probabilistic zones, that the true magic of atoms happens. Chemical bonding. When atoms come close, their electrons interact in intricate dances, sharing space or even leaping from one atom to another. This is how molecules are born, how water forms from hydrogen and oxygen, how the myriad substances of our world come into existence. The entire complexity of chemistry, biology, and technology is, at its heart, an exploration of the ways atomic clouds overlap and interlock. Atoms are ancient voyagers, ceaselessly moving and mingling. Some of the hydrogen in your body, the simplest and most abundant atom in the universe, was forged in the Big Bang over 13.8 billion years ago. Since then, atoms have cycled through stars, planets, oceans, and living things, becoming part of who you are now. Each breath you take, each sip of water, passes atoms that have journeyed across the eons, threading your existence into the vast tapestry of cosmic history. The numbers involved are almost inconceivable. In a single grain of sand, you'll find more atoms than there are stars in the observable universe, roughly 10 billion trillion, or 1019. In a human body, there are about 7 octillion atoms, That's 7,000, 1,000. Each of these atoms, tiny beyond imagining, obeys the same underlying principles, governed by the physical laws that have endured since the dawn of time. Despite their diminutive size, atoms are capable of incredible feats. The van der Waals forces between atoms, weak as they seem, are strong enough to allow a gecko to scale a wall, its toes clinging solely by the interactions of countless atoms touching the surface. At the frontiers of technology and science, the manipulation of individual atoms has unlocked entire new realms. Quantum tunneling, the ability for particles to pass through barriers that should be impenetrable, lies at the heart of modern electronics, enabling the transistors that drive computers and the sensors that read data from ultra-small devices. On the cutting edge, scientists now arrange atoms with exquisite precision to build quantum computers, whose power derives from controlling atomic-scale states. They fashion atomic clocks with accuracy measured in a trillionth of a second, relying on the unchanging rhythms of electron transitions within atoms. Through atomic force and tunneling microscopes, humanity has begun to sculpt materials just one atom thick, such as graphene, a substance with almost magical conductivity, strength, and flexibility. What emerges from this relentless exploration is a new vision of reality. The world, which once seemed solid and fixed, reveals itself to be a delicate interplay of fields and forces, woven at scales almost beyond belief. The study of atoms is far from exhaustive. Each advance uncovers deeper mysteries and grander possibilities. It challenges our sense of wonder and invites us to redefine the boundaries of what is possible. In their inconceivable minuteness, atoms are the gateway to understanding everything from the vastness of the cosmos to the inner workings of life itself. Each discovery, each experiment, illuminates not just the atom's structure, but our place in the universe. For while atoms are the smallest building blocks of matter, within their enigmatic boundaries lies the foundation of all creation, a world both tangible and mysterious, finite in size but infinite in potential.